This video covers factorials. A factorial, which we write n with an exclamation point or x with an exclamation point, or really anything with an exclamation point, means that you take the number and multiply it by the numbers less than it until you get to 1. So you can see I wrote n factorial is equal to n times n minus 1 times n minus 2, and I continue until I get to 2 and then to 1. So for example, what if I have 4 factorial? So 4 factorial would be 4 times 3 times 2 times 1, which is 24. Factorials can get very big very quickly. So look at 9 factorial. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? A bunch of numbers. It's 362,880. 2 factorial, much easier. It's 2 times 1, which is 2. 1 factorial is just 1. One that doesn't really make any sense, but just go with it, because that's what my teachers told me, and that's what I'm telling you. It's a rule. 0 factorial is 1. There isn't a number, like we're using just natural numbers here. We don't have a natural number less than 0, so we just use 1. It makes the whole thing work. Notice this little box I put here. I want you to find the factorial button on your calculator because it will make this whole section easier and a couple more sections to come. So we want to be able to find this button and use this button. I don't want you having to hit 9 times 8 times 7 times 6 like that. That's crazy. That's way too much work. So look on your calculator and see if you can find something. Sometimes it's above in like a second function of your keys. Also, I picked out a calculator that I noticed students have a lot or have something similar to, where if you don't have a button that has an exclamation point on the home screen, it might be hidden under the PRB, and so I wanted to show you this picture of what that could look like. So if you happen to have a PRB button, you want to select it, and it opens up a menu that has other things in it. And you can see here there's the exclamation point, so that's how you get to it. That NPR and NCR, we're going to use those in this section as well. I did attach a couple videos to our weekly module of some common calculators, just some YouTube videos. If you can't find the buttons on your calculator, I highly suggest going to YouTube and looking and seeing what it can do. There's a lot of different calculators out there. I know some of them. I don't know all of them. So without me being face-to-face with you, sometimes it makes it hard for me to give you direction there. But YouTube has a wealth of data and stuff for you to look at. So if you can't find it, you might want to try that as well. All right, so let's go back, and hopefully you found your factorial key now because I want you to practice some factorials. So I gave you 5 problems here that I do want you to try using your calculator buttons. So some really plain stuff like 3 factorial, 5 factorial, do some addition, some division. Give those a try, see if you can get the answers, come back and check out what I did on the next screen. All right, so I'm showing you what they mean. I don't expect you to be hitting these buttons. I want you pushing 3 factorial and getting 6. I want you to push 5 factorial and get 120. 2 factorial plus 3 factorial, so 2 factorial 2, 3 factorial 6, 2 plus 6 is 8. For 5 factorial, over 2 factorial, I really want you to put those two things in your calculator. It would give you 60. But kind of what you're seeing here, and I can show you, is that you have some canceling out. That's not working really well. So 5 times 4, 20, 20 times 3 is 60. 11 factorial over 10 factorial, see this 10 down to 1 and this 10 down to 1? Those are in common, so I would just get 11. But again, put in your calculator. Don't do this by hand. All right, so once we're used to this factorial button, we want to expand on this and talk about a permutation. A permutation of n things, taken r at a time, is the number of ways to order, which that's a really important word, order r of n items without replacement. And here n has to be at least as big as r, if not bigger. Really, really important is that the order of selections is important when finding a permutation. So this is our formula. NPR is n factorial over n minus r factorial. But as we've just seen, most calculators have buttons for permutation. Please find it. please find the key on your calculator because it will make this so much easier for you. If yours does not have it and you're having to do this with just the factorial button, then make sure you're using parentheses around the denominator. That way you get things right, but I really, really, really encourage you not to have to do this by hand. Find a calculator that has this button. It should be on most like $10, $15 calculators, a very common key. All right, so let's try some examples. I will show you the long way just in case you think you're going to do it that way, but I really want you doing this in your calculator. Important to note, when you go to put this in your calculator, generally you will have to start by putting the first number in. So like see this 8, so I would push 8, then I would find my permutation key and I would select 3. So if we were back, and let's go back here, if I was back on this kind of calculator, I would first push the 8, then I would push the PRB button, I would select the NPR button, and then I would push 3 and it would give me the answer of 336. So if I want to find the permutation of 10, choose 7. I would push 10, I would push the permutation key, I would push 7, it would say 604,800. And if I had 4, choose 4, it's just going to give me 24. All right, let's talk again about what this means. This is if I have 8 things and I select 3 and I put them in order, I would have 336 ways of doing that. So say I had 8 people in class and I selected 3 of them to give a speech. Once I selected these 3, it would be, I would say you go first, you go second, you go third. It would pick how many ways I could order it. If I had 10 things and I was selecting 7 of them and putting an order to it, so say we had 10 people run a race and we want to know how many ways the first 7 people could finish, there would be 604,800 ways they could finish. This is if I have 4 things and I select all 4, right? So I'm using all of them. How many ways could I order it? It would be 24. All right, so let's try a couple more. Let's say we do 8, choose 5. Again, in my calculator, I push the 8, I push permutation, and then I push 5. It gave me 6,720. 10, choose 3, gave me 720. 6, choose 1, gave me 6. It says if there's 6 things, I'm going to pick 1. How many choices do I have? I have 6. And then 5, choose 0. If I have 5 things and I decide to choose none of them, there's one way to choose nothing. You just choose nothing. All right, some interesting things to possibly remember. I'm not saying you have to memorize it, but sometimes it helps you when you're doing the work. N choose 0 is 1, right? We just said if there's N things and you decide you're picking none of them, you have one way to pick nothing. If you're going to pick one thing, right? So if I have N and I choose 1, I have N choices. And if there's N things and I choose all of them, then it's N factorial. All right, so when do we use permutations? We use permutations anytime repetition is not allowed and order is important. So let's do a quick example. Let's say Alexis has 8 songs on her running playlist. If she puts a list on shuffle, how many ways can the songs be played once each? So this is an example of a permutation because each song will be played once, so we don't have repetition, and the order is important. And if you don't think the order is important, I don't know, maybe you're not a runner like I run, and I think it definitely matters what starts me off, what I finish with, what gets me going through the middle. So I think order is important when you're listening to music when you're running or working out. So here I had 8, and I'm choosing 8. That gives me 40,320. So let's look at horse racing. In a horse race with 5 horses, how many ways could we bet on first and second place winners? Okay, so I put an order there saying you have to pick somebody to be first, you have to pick somebody to be second. So that's where they put the order in, and you can't have repetition because once a horse finishes, it can't go back and be first and second place. So if I have 5 things and I'm picking 2 of them using a permutation, that would give me 20 ways to bet. Well, what if the race got bigger? So now let's say we have 10 horses and we want to bet on first, second, and third place now. So put in more horses and made more bets. So I have 10, choose 3. That gave me 720 different ways that we could bet. Right. So close to a permutation is something called a combination. A combination of n things taken r at a time is the number of ways to select r of n items without replacement, and again, n is greater than or equal to r. How a combination differs from a permutation is in a combination, order doesn't matter, right? Just not important to us at all when we talk about a combination. Our notation, C for combination, so I have NCR now, and the formula is n factorial over r factorial times n minus r factorial. Again, I really want you to use the button on your calculator for combinations, because if not, things get ugly really quickly without using parentheses correct. If I were to put this on my calculator, I would really have to add another set of parentheses around the bottom to get it to do the combination correctly. So if you decide you just want to do it that way, know that you need one more set of parentheses that isn't shown right now. All right, so again, I want you to practice using your calculator, so make sure you're doing this along with me. Don't just look at my slides. Make sure you're trying this because you're the one taking the test, and I want to make sure you know what you're doing before we get you to the homework. All right, so this one, I have a combination of 8 choose 3. So 8 combination 3 says 56. If I do 10 choose 7, so I have 10 things and I'm selecting 7 of them, it would be 120. 4 choose 4. I have 4 things. I'm going to select all of them. There's one way to do that if order doesn't matter. 8 choose 5. So again, put in my calculator. 8, hit the combination, hit 5, I got 56. 10 choose 3. I got 120. 6 choose 1, I got 6. And 5 choose 0, I got 1. Now there's some interesting things going on here with combinations, and I want to point them out to you. So the first one, look at this 8 choose 3 and look at 8 choose 5. Do you notice that I have the same number? So what this says is if I had 8 things and I'm trying to select 3, maybe there's 8 classes you need to take to finish your degree, and you're going to take 3 next semester, so you have to pick the 3 you want to take. It would say there's 56 ways to do it. But it also says instead of picking the 3 you want to take, you could say, let's pick the 5 I don't want to take next semester, and you would still get 56 ways to do it. So it doesn't matter if I did the 3 or the 5, it's because 8 minus 3 is 5 and 8 minus 5 is 3 that I would get the same number. So you can see the same thing happens. Just one step down here, I have 10 choose 7 and 10 choose 3 are both the same. So there can be repetitions with combinations. That's perfectly okay. Like if I were thinking about this 6 choose 1, what would be the same? 6 choose 5. 6 minus 1 would be 5. So it's always the 1 like if I subtract it. So I just want to point that out to you that here's some interesting combinations to remember. N choose 0 is 1. N choose 1 is n. N choose n is 1, and then the combination of n choose r is the same as n choose n minus r. So if that helps you, absolutely use it. If it confuses you, then don't worry about it. You can just put things in your calculator. All right, so when do we use combinations? Combinations are used when repetition is not allowed and order is not important. So let's say this, Stan has 8 suits. How many ways can he select 2 to pack for a business trip? So this is an example of a combination because he has to pack 2 different suits, so he can't repeat it. He can't put the same suit in twice, and it doesn't matter which order he puts the suit in. They're both going in the suitcase. So from the 8 suits he has, he selects 2 of them, and that says there are 28 ways to pack. All right, so here we are selecting classes. So to receive a minor in performing arts, Andrea must take 5 of 12 courses offered by the performing arts department. How many ways can she select? Can she select 5 of the courses she's going to take? All right, so I know there's 12 possibilities, and she needs to pick 5. So I do 12 combination 5, and it says 792. And let's say selecting side dishes. So we have a grocery store offering a turkey dinner with a choice of 3 sides. If there are 6 sides to choose from, how many ways can the dinner be ordered? Right. So there's the assumption you're not just going to order the same side over and over. You're going to select 3 distinct things. That'll make it more interesting. So we're not doing double mashed potatoes or double macaroni and cheese here. We're saying we're picking 3 distinct things. So I had 6 choices. I'm selecting 3, and it says you have 20 possibilities for the ways you can order sides. Okay, sports games. Let's say we had 16 people are competing in a tennis match. How many games are needed for each person to play every member in the competition once? So, order doesn't matter because like any football team or any baseball team or whatever, when a team plays, if the Bucks play the Saints are playing the Bucks. So the order that you select them is not important. So we have 16 people, and repetition is not allowed because you can't play yourself. So we just need to pick a combination of 2. So the combination is because order doesn't matter. So I say 16, I hit the combination, I pick 2, and it says 120. I didn't really do a U-try in this video, and that's because I put a practice quiz on our weekly module. So when you finish this video, right afterwards, you'll see there's this little practice quiz. Practice means it's not counting for any points, but it would be a way for you to see if you understand this material. So when you look at it, you'll see it'll ask you, hey, is this combination or permutation, or how many ways can I do this thing? I mixed it with counting principles as well because I know that gets confusing to some students. So that's why the U-try is missing here. I threw it on Canvas, so check it out there and see